Hello, welcome to IoT DevFest, Wind River's presentation on migrating your legacy industrial critical infrastructure system to IoT securely with virtualization. So today I'm going to talk to you about how we look at critical infrastructure systems and think about those from the context of cybersecurity. My name is Alex Wilson. I'm Director of Market Development with Wind River. And I've been at Wind River for over 20 years now, working in the embedded industry, and in fact in the embedded industry for over 30 years. And in that time, I've looked at different types of systems and how you might look at security. And especially recently, as you start to think about connecting those systems to the internet or IoT, then we need to think about security even more seriously. So with that, I'll start my presentation. Okay, so I mentioned IoT. Really, the top-level driver around the industry today is around digital business transformation. That is the use of technology to radically improve the performance or reach of enterprises. It's looking at changing how we do business, changing on a new approach for business strategy, if you like, a focus on things like customer experience, a shift towards services or microservices-based business models. And with that comes increased digital competition from either existing competitors or even new competitors entering our marketplaces. And really the drive here is to increase efficiency, safety, and sustainability, especially in the context of the fact that natural resources are becoming more scarce and more expensive. Energy prices tend to fluctuate quite heavily, but are very high. And of course, increased labor costs leading to more automation and more automated systems. And with that, we think about the need for smart maintenance approaches. We can't afford to keep sending engineers out into the field to fix equipment every time we have a problem. So we have to figure out through the life cycle of our equipment how we increase the efficiency of our systems and how we do smart maintenance approaches to that equipment. And increasing the quality of our equipment and the way that it's managed and maintained also really helps improve our product quality and gives us the ability to start thinking about more flexible manufacturing services that allow for that ease of maintenance. So really, the drive towards business transformation comes down to a number of things that impact our business. Firstly, we need to data enable our devices. This is what we call IoT, or I've called it industrial IoT here, to differentiate it slightly from commercial IoT. Also, we look at things like our through-life costs of our systems in much more detail. So how do we think about upgrading our systems and maintaining those through things like consolidation and virtualization. Things like software-defined infrastructure and these kind of topics. And at the same time, we have to think about systems that have a requirement for functional safety. This is still a high requirement within for instance, within our factory. We have robots and machines that have functions that could cause harm if they go wrong, and so we have to consider functional safety. But more importantly, and the topic of this talk, is around cybersecurity. We're basically connecting our systems, our devices, with our data to the industrial IoT, and so we need to think about how we protect them from cybersecurity threats. So let's look at a little bit more detail about IoT. So as we think about digital transformation, we're thinking about how we data enable our devices, our sensors, extracting that data and then using analytics techniques to make business decisions. And these business decisions lead or could lead to changes of control back to our devices. This is our loop we're creating. And having data-enabled intelligent devices is what the industrial Internet of Things is all about. And it drives digital transformation. Data-enabled intelligent devices and sensors mean we can optimize our systems based on business decisions at the highest level and provide us capabilities that enable the factory of the future, or truly connected healthcare, or automated or connected and public transportation. These new industrial Internet of Things systems drive digital transformation by enabling new services and microservices that allow us to examine in great detail the operation of our systems, leading to things like reduced cost, increased efficiency, greater flexibility in our manufacturing and production systems. So these are all good things. Now, as we look at implementing the industrial Internet of Things, we come across a couple of terms. I mentioned them earlier: consolidation and virtualization. So let's look at some underlying approaches to virtualization in the context of the Internet of Things. If we look at the diagram here and start with the east-west consolidation, this is taking a number of legacy, or for that matter, new types of systems, and consolidating them onto a single platform. The reason we do this is it eliminates the number of subsystems that we have and provides savings across our enterprise in terms of space, weight, and power. We no longer need to worry about cabling to each of these systems and communications. We can consolidate that on a single system and reduce our power and weight requirements. Also, these systems typically have a hard real-time control requirement and possibly a functional safety requirement. So the key characteristics here are around real-time control and functional safety. Now, if we look at the north-south on the diagram, as we start to think about cloud and fog architectures, we're looking more at the flattening of the topology, running services on standard server equipment, maybe in a local cloud or fog, or maybe up in the cloud itself. And the main characteristics here are around scalability, performance, and high availability, the ability to deploy services where we need them on demand and at any time. So these are two different approaches to virtualization, and Wind River has experience and market-leading products in both of these domains. Now, the key around data transformation, digital transformation, is the data. We're making business decisions based on that data. And of course, we're connecting our systems to our network in order to extract that data. And so that exposes our systems to vulnerabilities. So I don't want to go into another list of yet more hacks. I've listed some here for you to read if you're really interested. We see these kind of things daily. But the key message here is that as soon as we start connecting our systems or into systems that are connected to the internet, we expose these systems to threats and vulnerabilities we may not have designed them to cope with. We may have assumed early in our design that our system was not connected, it was isolated. We did not need to consider cybersecurity. We may have done some work to ensure our system was safe from physical threats, but ignored cybersecurity and its implications, especially through the life of the product. In fact, if we think about the goals of digital transformation, we're going to use data to make business decisions. So any impact on that data validity could affect our business decision-making process and lead to unwanted circumstances. Data becomes the most important part of our system, and so must be appropriately protected. So as we move through this, Wind River has developed a new document, IoT Critical Infrastructure Project Checklist, which we can make available to you, or you can download from our website. And really this looks at items you should consider as you migrate your critical infrastructure systems securely to the IoT. So whether you're developing a device that will live in an isolated system or one that will be connected to the IoT, throughout its development lifecycle, cybersecurity concerns are real and must be considered throughout the lifecycle, from design to decommissioning. You will likely want to isolate your critical code from the rest of your software, including your IoT communications interface. This minimizes exposure of your critical software from potential security threats. And we came up with several steps you could take that allow you to plan for this. Firstly, having a cybersecurity development plan. And I'll go into these in more detail as we move through the presentation. Secondly, a development process. This is equally as important as our analysis of cybersecurity threats. To make sure we secure devices in all phases of operation, as I mentioned, from design through to retirement of our system. And then, of course, securing our communication links. We can use virtualization to partition our system and separate our safe or certified applications and IoT applications from critical data if then it's not needed to be transmitted. And of course, we have to continually throughout our life cycle examine our cybersecurity threats, keep monitoring in terms of new threats, and update our system accordingly. And a new function that we're seeing more recently is the addition of real-time security analytics, the ability to look at things that are going on in our system from a security perspective and take the appropriate response. So let's move through these and see how we might go about protecting our IoT critical infrastructure. So when we consider cybersecurity, we need to start right at the beginning of the project and start thinking about what risk we are exposing our valuable data to and what the consequence of that exposure would be. This leads us typically to follow industry guidelines and start a cybersecurity development plan, and more specifically, do a risk analysis of our system. Here we would map particular incidents and figure out the consequences of those incidents. Let's take an example. If we think of an IoT device that is supplying data for our decision process. So that could be your attack surface. A malicious actor remotely logs into our control computer and reads the data off the disk. So you would have to figure out what is the likelihood of that happening? What is the impact based on what data you are collecting? Does someone in your organization have admin privileges to log into that computer and read the data? Or is it handled by an outsourced IT company? What is your current strategy to protect this from happening? Do you have any way to detect when that happens? If you can detect it at all, do you have a strategy of responding to this threat? And how would you recover your system and maybe your data? So these are questions that you would ask as you develop your risk assessment plan. And we use known methodologies to go through processes that work out the business justification, the return on security investment that we would need in order to protect our system. And one methodology that's becoming more common is the NIST Cybersecurity Framework. So NIST is the National Institute of Standards and Technology and a part of the US Department of Defense. And they were tasked with creating a cybersecurity framework for critical infrastructure. So although US-based, you can see that the framework has not only been adopted across many critical infrastructure segments. You can see here medical, energy, all the critical infrastructure guides that are listed on the Department of Homeland Security. So this covers industrial, energy, dams, all sorts of areas, transportation. But it's also been adopted by other nation states, and I've given you some examples at the bottom of the slide here. The NIST Cybersecurity Framework is designed with the intent that individual businesses and other organizations use an assessment of the business risks they face to guide their use of the framework in a cost-effective way, as we described on the previous page. So this framework takes you through a process to identify, protect, detect, respond, and recover from cybersecurity attacks. It provides a process for your company to assign business decisions to threats that allow you to allocate the appropriate resources to protect your data. Wind River also provides services to help to develop your security framework, the Helix security framework. Our team is highly experienced and successful in the security field that spans critical infrastructure market segments, including aerospace, defense, medical, industrial, networking, and transportation. So our team works closely with you as a customer to understand your system and the operational requirements, while systematically determining the assets, the vulnerabilities to those assets, and the required security implementations to protect those assets. They develop the security assessment in collaboration with you to ensure alignment and practicality, ultimately resulting in a security assessment report and security policy. Our security offering includes a compendium of security implementations based on the industry standard, confidentiality, integrity, and availability, the CIA triad, which I'll cover on the next slide. Each of these principles is broken down to look at how your data would be compromised and what protection you could offer. So let's look at the CIA triad model in slightly more detail. So the Cybersecurity Development Plan could use the CIA triad as a model to look at how your device and data security should be implemented from three aspects. And those aspects are confidentiality, how we keep our device and data secret; integrity, how we keep device and data trustworthy so that we know we can make business decisions based on that data; and availability, assuring timely access to our data and device at all times. And think of things like denial of service attacks that could prevent you accessing data you need to make your decision. So all of these things would be taken into account as you go through developing your cybersecurity plan. As part of your development plan, you'll come up with, or you should come up with and develop a cybersecurity development process. This example I'm showing here is our cybersecurity development process within Wind River. But this covers a number of aspects during our software development phase of our products, from assessment, the very early stage of our project, architecture design, reviews and definition, the actual design of the software architectures and reviews of those designs, and then through to implementation, testing, validation, and finally deployment once we finish deploying our software. And there are various tools in the marketplace that you can use. I've listed some of them down at the bottom here to go through and check various aspects of your cybersecurity development. And this security development lifecycle is very important when you think about developing code and making sure you develop code that doesn't have security implications and known problems with the code. The third aspect of our guidelines looks at the securing your device. And this has to be throughout the life cycle of the device. So we start with the design, move through the boot phase, the runtime phase, and the power down phase. And in fact, a further phase should be included around retirement of your device. As we look at the design, we've talked about the secure development process, but you also may need to go as far as thinking about signed binary deliveries, making sure that the code that you develop is the code that's booted on your final system. And there are some standards you might follow that start to help implementing security throughout the lifecycle of devices listed at the bottom of the slide here. The boot phase is critically important. Here we're talking about making sure that our system does boot that signed binary delivery. So here we're making sure that someone hasn't changed the firmware on our system, they haven't altered the actual executable code, and the system boots up what it thinks is valid software, but in fact it has a malicious payload included. So we need to make sure that that boot process is protected and running the correct code. And then once our code is running, and this is more the topic of this discussion, we're talking about how we can isolate and separate code out through use of partitioning. Of course, we can use other methodologies on our system depending on our requirements, cryptography, user management authentication if we need it, and of course audit logging. This helps us during our recovery phase and forensic phase. If we do have any security faults, we can look through and find out what happened and how we protected our system. And of course, power down, and this includes also storage of data on our disk. So do we add encrypted disks? How do we sanitize our data, especially in onboard memory? How is it protected from people extracting that data after the power down phase? So we have to consider all aspects of our system as we go through securing our device. Now, of course, we're also talking about IoT, so we need to think about how we get data from our device in a secure way up to our IoT systems. And so we have to think about securing communications. So this adds a number of areas where we might think about adding additional capabilities, things like digital certificates. This gives us the ability to make sure that we trust and have the right authorization to access data. Remote attestation, where we're looking at making sure we can monitor security aspects of our devices. Looking at runtime security in terms of how do we transmit that data up to our network? What network security features are we putting in place? Are we using the latest security protocols? Do we need to implement firewalls to protect our system from certain sites? So this is looking at the secure communications aspects and making sure that we've not only secured our device, but also secure the communications so that we can trust that our data is being sent up to our network in a secure manner. So we've looked at securing our device and securing our communications. The fifth item that I had on the list was around partitioning and separating our device to make sure we can protect it from a security perspective. So in a lot of systems now, I talked about consolidation and virtualization earlier on. We can make use of that and new technology to virtualize and separate our secure legacy or even new applications from our non-secure IoT applications. So our hardware systems now have the capability to create enclosed spaces, virtual machines, or areas that we can keep separated using hardware and software techniques. That means that we can really protect those areas from cybersecurity threats and manage how data is accessed within those devices. So our secure applications can exist on our system and only provide access to data that they're allowed to. And we can check that data in great detail to make sure that it hasn't been compromised through use of techniques such as certificates and keys. So this allows us to not only have our secure legacy applications hosted on our new systems, but also add new IoT functionality without recertifying or retesting those legacy applications, because we can create a new sandbox with those new applications and add those to the system without causing any problems to the original system. So this allows us to add new capability without increasing the project risk and the retesting of our legacy applications. So this is a very powerful technique and has been used quite successfully by a number of industries. We also talked about looking after our system throughout the life cycle of the system. So one other aspect that virtualization gives us is the ability to update and change applications. So for example, we could introduce a new application which is an update to our legacy application, test that it's okay, prove that the security features are correct and not causing any problems before we retire our legacy system. So this gives us a very nice way of maintaining security and maintaining the capability of our device throughout the device lifecycle. Now, as we think about the life cycle, we need to think about monitoring of security threats that we see within the outside world. And so there are a number of ways you could do this. This example here shows you the number of security alerts issued by the US CERT organization and through MITRE with the CVE alerts. And I've listed along the bottom of the slide here a number of the kind of alerts that you might have seen over this time period. This particular slide is going out to the Heartbleed alert here and the Ghost alert that we've seen recently. But the really interesting thing here is if we look at the number along the top, we can see the huge increase in the number of alerts that these organizations are putting out that we need to monitor. And the number of fixes that we need to implement in our systems if we're deploying different types of systems. So as we think about the life cycle of our product, we have to figure out how we can maintain and update our systems based on the monitoring of these kinds of these releases. So for each of these alerts, we would need to find out, okay, is it vulnerable to that alert? Looking back at our security risk assessment and policy, does it change anything in our risk assessment? Does it have a high impact on our system, or can we ignore those alerts? So we have to go through a process with each and every one of these types of fixes that allows us to figure out what is the impact, what needs to be updated on our final system, and how we go about doing that. So we would do that through our remote monitoring an update process. So what we would do, and this in fact is Wind River's alert process, we monitor the alerts, as I said on the previous page. We do an analysis on those alerts to see how they might affect our products, that we can then alert our customers through our messaging process, such that they can see those alerts have been issued. We can say whether it affects a product, which products it affects, what the defect is, and how they download the patch for that and update their systems. So as a customer, you can make use of this to update your systems that are based on our software, but you would also need to implement such a process for your software systems, such that you could maintain and update the cybersecurity protection that you have within your system. So you would need to figure out, as I said on the previous slide, does a particular alert affect your customer system? And in fact, if you go onto the NIST and the MITRE pages, you can see which types of system are affected and have put out updates to these kind of fixes. And you can think of, especially in the IoT world, when we look at consumer devices, if we think of recent attacks that made use of webcams and internet exposed devices to create huge denial of service engines that could attack other systems, this is what we're really looking for. And using this database, we can make sure that we don't fall into traps that have already gone out there and already affected current systems. So you need to make sure that your systems are kept up to date and using the latest fixes and technologies. So a new area to cybersecurity is our last bullet point on real-time cybersecurity analytics. And this is something we're starting to see, especially in IT systems now, the idea of proactive analytics or proactive security protection, which allows customers to start thinking about the response recover phase of our cybersecurity framework. And this allows our system to be self-monitoring and autonomous in certain actions. So we can run something like the Axon Predict interface on VxWorks and allow it to monitor for certain aspects of cybersecurity. So as well as doing very good work around providing valuable feedback and analytics for IoT uses, such as monitoring temperature fluctuations or vibrations on our device, we can also think about how it could monitor security aspects, things like data leaks, insertion of malicious code. It could look at communications channels to see whether it's as expected, or whether there's unnecessary communications, data going out of the system that we weren't expecting. And we can set up our analytics to alert our operator or take some other action, like closing down those communication channels. So this is a really nice way of enhancing our system to provide not only the basic protection, the static protection that we would during the design phase of our project, but throughout the life cycle of our project, this allows us to monitor security aspects as well as other IoT aspects and provide valuable insights and data. So this is really a leading edge in terms of how we can offer proactive cybersecurity analytics. So Wind River solutions offer a full spectrum of security for each of the layers within our IoT system. And these solutions span the end-to-end picture all the way from deeply embedded sensors and actuators all the way up through cloud services. So our offerings include secure solutions for combined safety and security, as well as for open source Linux-based systems and function virtualization. Symix, our simulation product, provides unique value for testing from individual devices all the way to fully integrated systems. Each of our products is developed with a robust security process to ensure that our customers can have the highest level of trust in the solutions they rely on from Wind River. These processes include best-in-class security incidents response, which helps ensure our customers can keep their security up to date throughout their system's life cycle. Customers leverage our professional services to provide support for unique security technologies, to provide system or subsystem security assessments, and to integrate solutions that can result in out-of-the-box secure operational capability. So I hope I've given you some good insights into what Wind River does and how you might think about security in your IoT systems. So really, in conclusion, I would say, firstly, cybersecurity has to begin with the project design at the very start of the project. Security isn't something that you can bolt onto your system at a later date. You have to think about all aspects of your design, from the process you're using for software development all the way through to deployment, maintenance, updates. It has to last for the entire project lifecycle. In fact, you even have to think about, as I mentioned earlier, retirement of your products. I was at a speech recently where the speaker said they had purchased some medical devices from eBay, and those medical devices still had patient data within those devices. So this is something you need to think about as you retire your products and projects. Legacy systems can be brought into the industrial Internet of Things using virtualization, isolating them within an environment, making use of hardware and software virtualization to make sure they're separated from our IoT communication channels in a safe and secure way, while still enabling us to extract the data we require and transmitting that securely up to the IoT analytics engines. Virtualization can also help ensure cybersecurity in our systems by isolating potential vulnerabilities from our critical code and communications. So any critical code that we have can be kept separated and make sure that we really don't compromise that by exposing it to cybersecurity vulnerabilities. So with that, I will close the presentation and we will see if we have any questions. I had a question on, can you tell us more about how virtualization can help from a security perspective? So when we think about virtualization, what we're doing is we're creating a virtual machine that allows us to run our code in a controlled manner. And because we're creating a virtual machine, we have much more control over all aspects of that virtual machine. So if you think about the virtual machine, it has I/O, it has memory space, it allows our application to execute. So virtualization, from a software perspective, allows us to configure that machine and very much control exactly what communications we allow. So what access do we allow that application to the system? What I/O interfaces do we allow that application to have? And by having that control, it gives us much more capability around protecting those interfaces from a security perspective, because we can analyze it in a lot more detail and make sure that each of those interfaces is controlled and secured in the way that we need for our business requirements. So here's another question. You talked about security analytics. Can you expand on that with an example? And do you have cloud-based or edge-based analytics that you offer? Okay, so the example I gave was based on the Axon Predict product from Greenwave running on VxWorks. So this is a cloud-based or edge-based analytics solution that runs on VxWorks. An example, let me think. So one example might be something like, I mentioned the denial of service attack earlier on around availability of data. One thing you could do with the analytics is set some parameters that monitor your incoming web traffic. So we know we have a connection to the outside world. We could set up our analytics engine to say, okay, we're expecting this amount of data. This is what our system normally does. If it goes outside of these parameters, then do something. And that do something would be based on our security policy that we developed as part of our risk analysis framework. So for example, it could shut down that communication channel and restart another channel to talk back to our host to say, hey, we're being attacked. or it could do any other thing that depends on your security policy. And then I have a further question. I think that was related to my virtualization answer earlier. Can that be done in isolation without any policy on the host hypervisor? I guess I'm not sure what the question means. So you have within the embedded system that I discussed here, running on VxWorks, you're building you're really building this is a very different hypervisor to that you would expect on a desktop platform. So you're building the virtual machine that runs your application very much in a controlled manner. It's running what's called a Type 1 hypervisor that executes from startup on the hardware, so you have full control of the hardware. And the configuration of that hypervisor and the virtual machines is done during your design phase. So it's not the same as a Type 2 hypervisor, which is kicked off on a host environment. It's a very different type of system. So the question is, can that be done in isolation without any policy on the host hypervisor? So the development of that hypervisor really is done as part of your overall system development. And so I think the policy or the security policy that you would install would be part of that overall system. And so I guess the answer is then yes, it is done in isolation from the host hypervisor because it's not really a host hypervisor in the same sense. I hope that makes sense and answers, or partly answers your question. But if not, feel free to reach out to us and we can talk more about that. I'd like to thank you for attending my call, and reach out to Wind River or myself if you have any further questions or would like to get copies of any of our presentations or our cybersecurity policy. Thank you.